Alright, so today we're studying another idea called the square root property. Square root property goes something like this. It's a type of equation. You can think about it as a big family of equations that they all look like they have the same format. And when they look like they have these specific format, we can solve all of them with this one idea called the square root property. Okay, it's going to be the perfect medicine for solving a bunch of equations. The format that they require, that's going to be applicable, is like this format. You have x, or the unknown variable, squared is equal to some number on the right hand side that doesn't have any x's. If it looks like this format, we've got the perfect medicine for it. It's going to be called the square root property. Here are other examples of equations that have the same format. That one right there. A perfect square is equal to a number. Perfect square is equal to some other thing that doesn't have any x's. All these, as long as it's a perfect square is equal to some other stuff that doesn't have any x's, we can apply the square root property. Okay. Anyways, talk is cheap. Let's do it. Let's start off with this one. So we're going to use previous ideas to do it step by step, and then we'll package it into a theorem. So it will go something like this. You could say this is x squared plus negative 25, and that's equal to 25 plus negative 25. And you could justify that by saying, well, I've just added a negative 25 to both sides. I can write it. Oh, that's not the kind of teacher I am. Here, I'll write it nicely. Negative 25. So cancellation law of addition says I can add a number to both sides. That gives me that x squared plus negative 25 is equal to 0. That's by additive inverses. And now it looks like, well, there's many ways to proceed, but one way to proceed would be to rewrite this as x squared minus 5 squared. And the reason that might be useful is because now it looks like a perfect square minus another perfect square. Perfect square minus another perfect square. Oh, we're experts at that. That's a famous polynomial that's called a difference of squares. And we all know how to factor it. It becomes x minus 5, x plus 5 is equal to 0. Difference of squares. In case you're rusty on that, you could also try splitting middle term. I know there's no middle term, but you could place one in there, like 0x would be a legal one to place in there. We've done that in other videos. Anyways, now we have this beautiful setup here. We have something times something is equal to 0. And every time you have something times something is equal to 0, what time is it? It's 0 factor theorem time. This is the z, or 0, not 0, 0 factor theorem time. And so that means that I can take my problem and happily break it up into little tiny baby problems. These problems are for infants. This one's degree 2, maybe a little harder. Now we've broken it up into little baby problems. X minus 5 is equal to 0, or x plus 5 is equal to 0, with using the magical powers of the 0 factor theorem. 0 factor theorem time. And so now I could add 5 to both sides. That would give me x is equal to 5. I could add negative 5 to both sides. It's cancellation law of addition and some other minor things. I'll call them by inspection. And now I've got my solution. I've got two solutions. Degree 2 problem, two solutions. I told you, fundamental theorem of calculus. Proven by Carl Gauss. You guys should look him up. Carl Gauss was born in 1777. At the age of 17 years old, he wrote his PhD thesis. And in his PhD thesis, he wrote the fundamental theorem of algebra, which says if it's degree 2, you've got two solutions. If it's degree 3, you've got three solutions. That's the fundamental theorem of algebra. Okay. By the way, Gauss died at the age of 87. This guy's got 7s everywhere. Look, he was born in 1777. At the age of 17, he did his PhD thesis. He died at the age of 87. He had 7 toes and he had 7 eyes. I'm just kidding. I don't know. Super famous. They call him the Prince of Mathematics, Carl Gauss. Degree 2 equations, beautiful. These steps are so repeatable that we can package them into one theorem called the square root property. Before I do that, why don't we practice just one more time to make sure we're all on the same page. So you've got x squared is equal to 36. And we're going to call this our given. And then we're going to proceed like this. X squared plus negative 36 is equal to 36 plus negative 36. Cancellation law of addition says I could do that. This gets killed and I have x squared minus, I'm going to call this 6 squared because I can see it's a perfect square. 6 times 6 is 36. I told you. And then I have that x minus 6 times x plus 6, of course, is equal to 0 by difference of squares. Now I have something times something is equal to 0. Every time you have something times something is equal to 0, what time is it? Z of t time. That means that either x minus 6 is equal to 0 or x plus 6 is equal to 0. Z f t. Okay? And then also you should know that this becomes x equals 6, x equals negative 6 by just adding that to both sides. And so we've solved our problem. Check it. If I take negative 6 times negative 6, do I get 36? Yes. If I take positive 6 times positive 6, that's it squared, I also get 36. By the way, the short abbreviated way of writing this, this long thing, x equals 6 or x equals negative 6, people often write x equals plus or minus 6. This is just abbreviation of the previous line. And so all these steps are exactly the same as we had before with the 25, and so we collapse them into one powerful theorem called square root property. Square root property. It says that you can go from here to here in one step. Okay? So alternatively, rather than, what you should do this a few times in your life so that you own the steps and you make them your own. But once you get used to that, you can just quote the theorem, and it's a package all the steps into one, and it will look like this. It will look like this: x equals plus or minus the square root of plus or minus 6 by square root property, just like that. Okay, that's the introduction to square root property. Now, I know what you might be thinking. I know what you might be thinking. You might be thinking, wait a minute, what if it wasn't 36? What if it was more like x squared is equal to 17, where it's not an even square? Would that be a little concerning for you? Maybe. Maybe some of you might be thinking that. So that we should address in the next topic. What if you don't have a perfect square on the right hand side? Alright, come back and we'll have that little talk.